All right, so first of all, an apology. So I originally intended to show this talk last month, but then I had, unfortunately, to drop out. Well, here I am, and I was so close to dropping out again because I have to go right after the meetup to some place and fly away tomorrow. But anyhow, here I am showing you what I did with JavaScript. This is not a part where you usually show either your company or your open source projects. I don't have any open source projects that are worth mentioning. What I do have are open doors projects. That's kind of cheesy, I know, but there's some meetups, and it's really great for me to be here at the original ViennaJS meetup with us doing the JS meetup in Linz over there, and the Technologieplauschall meetup, which are run completely differently, and it's nice to get new influences from around, especially from here. This meetup is very well known back there. I also do a conference in Linz and a weekly podcast about all news in JavaScript and web technology, even though I rarely do actually any JavaScript. So, and this story that I want to tell you right now is something that started like you know the term Rauschgeschichte? Yeah, so this is kind of the opposite of that. So what I did when I reached my number 1,000 on Untapped, 1,000 unique peers, I thought to myself, so it might be worth looking for another hobby. This was a weekend where I thought, okay, let's drop the record and do something creative, create something new, create a new program, create new software. This was also the time where this image went around, like, which website are you designing today, this one or that one? This was also the time where I found this video. I'm not sure if you have seen this one yet. If not, I'm just going to show it to you.
They will help us put the groceries away. I think that
that's Sophia.
artificial intelligence
That's an artificial
will evolve
intelligence.
to the point where they will truly be our friend. Do you want to destroy humans? Please say no.
Okay, I will destroy humans.
No, I take it back.
Did you hear it? All right. So she, well, if you didn't hear it, just look at this likable, pleasant face looking at you, trying to destroy humans. So those were the influences that I had. So it was like every website looks the same. There's cool stuff out like artificial intelligence. Maybe you can do an artificial intelligence that checks which one of those two websites you have created. Like you don't have to choose for yourself. It just tells you afterwards. Spoiler and disclaimer, I didn't reach my goal. I'm going to tell you why. So for me, I come from a computer science and artificial image processing background. Funny thing, I was months over there, and I worked at the same company, not at the same time, but this was some time where I was working a lot with classification, machine learning, etc. So I tried, okay, let's wind up my own knowledge about artificial intelligence and especially neural networks. And I'd like to show you how neural networks works, like in general, like not super high level neural networks, but easy peasy neural networks, because I couldn't do much more. That's why I'm now a CSS developer. All right, so that's the most simple neural network. You have nodes and edges. You have input nodes and you want to have some output. So anytime you give some input to a neural network, some stuff that tries to find out what you're doing or what you're telling, you put it into one node, and this one node has a range from 0 to 1. This is a pretty limited range. So if you have inputs with neural networks, you need to have a lot more input nodes. And then you have some output nodes. So this is the result that you want to have, either Sophia talking to us, or in our case, something much more easier. And then you have edges in between those nodes. And what the edge does is just simply multiplying the input that it has and giving you the output. So as said, the most simple neural network. Also the most boring neural network, because there's nothing much more to it. You can pretty much predict what the outcome is there. It's getting much more interesting if you take so-called hidden layers. You can have multiple input nodes, like I said, and then you have hidden nodes in between. And each and every one of those nodes is connected. Those are those edges here. And those hidden nodes combine the weighted input they get over the edges. So if you have here some number between 0 and 1, floating point, not integer, and you put it on the edge, like let's multiply it times 2, then it gets weighed here like the mean of all those input nodes that it has. And it stores the value over there. And then it sends it back again to the output node and weighs it there again. You can have lots of hidden layers in between. The more hidden layers that you have, the better your result gets. And then in the end, at the output, you have also a number between 0 and 1. So This is pretty funny because you just have 0 and 1s piped through a network of nodes. And that's why my original goal of classifying websites to be either website 1 or website 2 was ultra hard because I couldn't think of all those input nodes that I have to create. You have to find inputs or a range of inputs that you can classify or that you can break down to 0 and 1s or something in between, like 0.5, 0.6, 0.67, etc., etc. So for me, that was really, really hard to figure out. That's why I came down to a much, much more simpler solution that helped me understanding how neural networks work. So that's why the title is Me, Myself, and AI, because I learned a lot from the neural network. And let's say the neural network learned a lot from me. So this is how a network is constructed. And then there's the activation phase. So the activation phase means like with your receptors in your eyes, your skin, whatever. You get some input, and this time it's input from zeros and ones coming from the input nodes. You activate the network, which means the input is transformed and stored in the hidden layer and moved forward to the output. So that's the activation phase. But you also have the training phase. So at the end, when you have the output, you can tell the neural network, okay, that's a good output or that's not a good output. You were expecting something else. And that's called the training phase. So the training phase or back propagation phase takes the output that you would have expected and propagates it back through the nodes. And those weighing algorithms here, like the multiplicator, like times 2 times whatever, is getting modified by a special learning rate so that it is adapted for the inputs to come. And you propagate back to all the edges. So now our edges have changed. They have now a different number in there. And if you give a new input, they will weigh this after the original input that you have been made. There's some variance there. You can even have some memory on those hidden nodes where you say, okay, I know that for some certain conditions this has to apply and not this one. But that's way too much for. So that's the basic neural network that there is. And with that, I thought, okay, that's way too much for me to classify to web pages, let alone create one on my own. That was the original goal, like have the ultimate web page generated. So there's no discussion anymore which one of those two you should take. So what I did then was, all right, so the complexity is in finding the right input and the right output. Let's do colors. Colors are pretty easy because the input is really, really easy. You have RGB, red, green, and blue. And you can break down red, green, and blue to zeros and ones pretty easily. Like 1 is 111 is super white, 000 is super black, like this green. And this is how North was created. North is the name from my little artificial intelligence because the North remembers. And staying with literature, this is the input that I've taken to train my neural network. Those are not nearly 50 shades of red and something shades of green. Shades of green are pretty interesting because you have things like cyan over there and mint cream over there. Turquoise, of course, which go more into the bluish area. So they are not really, really green. They're something in between. Very interesting from a neural network. And also a lot of shades of blue, where I also have some whites in there. And this was the input that I trained my neural network with. And this is now the JavaScript part. I used a library called Synaptic. So Synaptic, you can install it with NPM. It's a node library. It also works on the browser, which is pretty, pretty great because you can do the whole heavy lifting in Node and then do all the classification and creation in your browser. I got this one and I created a new LSTM. That's a long, short-term memory. That's a special kind of network, as I said, that has some edges to itself, so it can remember the states and knows over time what to expect. And what I also did, I created 3 input layers, 3 output layers, and hidden nodes, 2 layers with each with 10 each. So why 3 input layers? RGB, red, green, and blue, 0 to 1, one of those color components from a color. And I also wanted to have the answer from North, which color is that? And that's why I got 3 output nodes as well. So I wanted to have, is this a red color? Is this a blue color? Is this a green color? Why did I use 10 hidden layers or 10 nodes for each hidden layer? Trial and error. So the complexity is here. This is trial and error for the most part. The more layers you take and the more nodes you take, the slower your neural network gets, the more computation power it has to do, but the better the results get because everything is much, much more connected, much, much more interleaved, and you have a lot more stability with the calculations that you do, because there's always this one edge that can turn or flip your result up and down. So this is my basic neural network that I created with Synaptic, one of those things that I have shown you early on. I also defined the learning rate. So the learning rate is a factor that the edge can change. So if you do the backpropagation stuff, I say maximum 0.5 change in this one edge that you have. So this is like the Spannweite that you have here. Then I started learning. So for all my red colors, I activated the network first. So I created one of those hex codes. This to-number function is basically just, create a triple of zeros and ones. And I activated this network, and then I got some output. And I ignored the output completely there. So the output was not interesting for me. The only thing that I did was telling North that it's red. This is the only thing that I did. And I did the same for all the greens and for all the blues. So this was my original input, like learning all the reds, learning all the greens, all the blues, all the colors that you've just seen on the slides previously. Next step was asking North, okay, which colors are they now? Now I'm interested in the output. And I asked North, after learning all those, teaching all those red colors, I asked North, okay, what's this? And because I taught all those red colors, those were the last triple that I did, first the blues, then the greens, then the reds. North was answering me, that's red. And I said, oh, that's great. I asked about this color, a more darker shade of red. And North told me it was red. I had this standard shade of red, and North was also telling me that it's red, which was great. So I taught all those red colors, and North was telling me, okay, I know that this one is red. And that's not a part where North behaved kind of like a toddler. So I showed him a green color, and North, of course, was saying it was red. This is like, I have a niece, about 2 years old, and every time I ask her, okay, which one do you like more, your aunt or your uncle? She always says uncle because it's the last one that she heard. My wife found out she's now asking her, who do you like more, your uncle or your aunt? And she was always saying aunt. So that's the same thing with North. The last thing that you told her or that you told her is the one thing that she's going to repeat. That's why you need to train it. So this is just one iteration of all those colors. You need to have more. So learn a lot. Do 10 iterations of the learning process. Do 100 iterations of the learning process. Still not enough. I found that after 1,000 iterations of the learning process, my neural network was stable enough to give me the right output from the values that I learned. So some computation power there. I guess it was on Node.js with my machine about 5 minutes or so, where I just computed and tried to remember all the stuff that I told it. And so the thing is, this was originally meant to classify a color, to tell me which color this is. And that's actually a lot of computation power and a lot of effort to put into to get just a mere color. Why not doing something simple like? So I thought North is ready, but why not do something simple like HSL classification? Bring it to this color space where you have all those main colors ordered in a circle, like you can tell by the degree which main color this is, and then you do like chunks, like the pizza chunks that we got, where I say, okay, this is my green part, this is my orange part, this is my red part. This would be much, much easier to implement, much, much more robust, and no learning process required, because North made errors. North wasn't that good with it to begin with. The reason why you would use something like that is, and that's not a beautiful part. When I told North that I had a different shade set, like shades of orange, North did something really, really great. Those were colors North wasn't aware of. I showed him this left range of dark orange colors, and North all the time said, okay, this is a red color. And I said, yeah, my neural network can handle input that it wasn't prepared to. I kind of added a green one as well, so to test North, North is still robust like I was used to it. And yeah, North told me this is a green color. So this was the input, and North told me this was a green color. But the beautiful part, and that's the part where you use an artificial intelligence, like something that learns and something that can interact with the learned part, was when I was showing some light orange colors, North was inventing a new one. So North was inventing yellow there. It said, okay, I'm totally not sure what it is, But from my experience, from the things that you learned me, it should be this one. And it was really, really right. So that those were not that far apart in the color space. And every time it hit point on a yellow color that was, even with the same yellow value, so there was no error in between. And I felt like Frankenstein. It was amazing, you know. I got this output. I got it in some sort of JSON file, and I put it into some CodePen to see, okay, I can't see anything of this, any one of the diffs, so let's do a width and a height. And you get a little box and said, oh boy, this is just so great. Like, let's kill all humans. And yeah, and this is my major learning there. So that's why you use neural networks for that. Because they remember stuff, they interact with stuff, and that's just a tiny little neural network with just simple input and simple output and lots of hidden layers in between. You can't imagine what you do if you have lots of them, and I guess you need a lot more computation power and a lot more brain effort for that. So the major lesson here, neural networks are not for classification, but also for creation. So this thing learns, this thing remembers, and that's why it's called North. And this thing can invent new stuff based on the input that it got. Everything that you learn, it will use to create something that might fit or might not. I guess you heard from this artificial intelligence was it by one of our sponsors here that suddenly raged on Twitter because that was all the input he got from the internet. So the artificial intelligence that we had here was not. It was not its fault that it was that bad, behaved that bad on the internet. It was the world's fault that it learned nothing else. So not classification, creation. Again, the complexity lies in finding the right input and output vector. This is really important with that. If you don't know how to put all your input that you want to have in zeros and ones and how to name it, and if you don't know what you want to expect from it, you're screwed with neural networks. You have no idea how to fill it. Maybe break it apart in little things and try connect it into a big neural network then. In between can be solved through trial and error. I'm sure there's a better way. There's always a better way than trial and error. But this is where my research stops. So the more hidden layers you have, the more robust it gets. The more hidden layers you have, the longer it takes to compute. And one wonderful thing with synaptic chairs, do the whole heavy lifting in Node, do it on your machine. You can save the neural network in a JSON file. You can load it up in the browser again, and then you can use it for some interactive stuff like, okay, let's put an input with the color wheel and try to find out if North reacts to it. And with that being said, kill all humans. And if you have any questions, just ask me right now or find me on Twitter. Thank you very much. Spot on 20 minutes.
Questions?
Yeah.
How big is this neural network JSON file?
Oh boy. I honestly couldn't tell. I guess it was about 100K or something like that. So it just tried to, it depends on how big your neural network is, because what it does is some serialization of the data structure that you have here. And what it has is an object representing a neuron, that's one of those nodes, and an object representing the connections in between those neurons with the factor on which you multiply it. So I guess for the one that I had, with all the computations that I did, and with this extra long short-term memory, this extra factor that was stored with one node, I guess it was about 100K, not gzipped. Anybody else?
How many classes did North have at the end? So it's taking the input vectors and producing, in your example, yellow. So there's some number of clusters that it's created. And how many clusters has it created?
I'm not sure if I understand the cluster, like those neural network clusters.
It's either producing output vector between 0 and 1, or it's producing a discrete class. In your example you gave us, it was a discrete class.
Yes.
Which turns
Okay.
to yellow.
So what I did, you have all those shades of X, Y on Wikipedia. And I took all those colors and fed it with those. So North was able to create from this color wheel Roy G. Biff, red, orange, yellow, green, indigo, blue, and violet. It was able to create 3. So I had 6 colors that it was creating in the end. Yellow, magenta, which is violet, I guess, coming from Roy G. Biff. It wasn't able to create orange, though. And GB, I guess it was blue or indigo. I guess blue was learned, so it was indigo, like a shade of blue.
So what's the right quote, right answer, right? I mean, you could say brown should be there or brown should not be in there. This whole question of overfitting or underfitting.
Yeah, totally. That's one of the biggest questions there, which I didn't answer because I was just so amazed that I got yellow out there. But yeah, I was able to create some of those colors on the rainbow. There is no right answer. So what I should have done then was like learning North again. What it just brought me. Like again, like with the child, you come and you have this color. You don't know what it is, but you believe that's the color, and I should just have backpropagated it with the right input to justify my neural network. But it was able to create 3 more colors other than the 3 colors that I learned it, and that was the end result. I didn't do anything more with those colors, to be honest. Okay. Anybody else? Yeah, those are very interesting questions. Yeah.
Can you maybe explain a little bit how did the neural network create new colors? As far as I understand it, there's 3 output pins and with the
yeah. It needed to have so I just switch back to one important slide here, I guess, and that's way back. That's this neural network. So what I had in the end was 3 output nodes, and each node was representing a color component: red, green, or blue. So all those output nodes were connected with edges. Okay, so there was this one color where it wasn't sure on how to weigh this color. It couldn't find the concrete one there, which it had before, like red, green, and blue. The original red, and green, and blue are very easy to define with a 3-piece tuple. Like red is 1, 0, 0, green is 0, 1, 0, and blue is 0, 0, 1. And with the special input that I gave it, it wasn't able to find a concrete and discrete 1 at one of those components. So it gave me a 07, or it gave me 2 ones. I don't know how yellow is constructed, but I guess it's 1, 1, 0. So in that case, it said, okay, I think it's green, but it's also red. And then I had 2 output nodes giving me the ones. And that's how I created a new color. That's how it said, I'm not sure about that. Or it didn't say I'm not sure about it. I think it's both that and that.
Okay, so you get the probability above 0.5 for 2 output nodes, and it gave you like the combination of both. Because otherwise, it's always like
that was done by the edges. You know, if
but if you have 3 output pins and you have a probability for each color, you define green, red.
I wouldn't say it's probability. I'd say it's the math of those edges. But it was like the input components triggered the same calculations to produce both zeros and ones. I wouldn't say it's probability because there's more probability to it.
It's actually the probability.
It's actually, yeah, it is.
Or some value between 0 and 1.
Yeah.
In just the class with the highest value, predicted value, you take like your predicted class.
He wasn't forcing it to be.
I do have the feeling right now. That my statistics classes are far too way away from this point in time that I'm right now. I guess 10 or 12 years. And I also see that there are 3 or 4 people very interested in the topic. So I might consider that we go into a group and discuss this, because I'm really interested in how you approach this thing, because I honestly didn't. Because maybe I might learn something from that. Is it okay? Just also to keep a look on the time. Because let's do it like that, because I would be really interested in what you're thinking. And I saw one person over there who also had some input there. So it might be really interesting to discuss about. Anybody else?
All right. So I think let's make a pause. Thanks for the talk. Thank you for watching this talk. Down below, you can find our channel, ViennaJS, where you can find a lot of different videos about front-end and back-end JavaScript. And feel free to subscribe.